Basketball.
Oh my God!
It's physics.
Got money, and you know it. Take it out your pocket and show it. Know it. This away, that away. This away, that away. Getting mugged from everybody you see, then hang over the wall of the VIP like this away, that away. Yeah. This away. All right. Come on, come on! Woo! Feel the burn, baby.
Hi, I'm Peter Lightning Highwaters, here to talk to you about the physics of basketball. But before we can talk about the physics, we gotta crack down on the history.
The sport of basketball was created by Dr. James Naismith. He was finding a game that took good skill but not so much strength. Instead of using basketball like today, they used a soccer ball, and for the baskets, they used 2 peach baskets which they posted on each end of the basketball court. Therefore, boom goes the dynamite. Speed. Speed is determined by distance and time. The formula is distance divided by time. Speed is controlled by the athlete using friction to cause traction in running down the court. Let's time a basketball player's fast break.
That's what's up. 3, 2, 1. Ew.
Luke's first trial was 5.4 seconds. His second trial was 4.1 seconds, and his third and final was 5.1 seconds. The total distance he ran was 20 meters. Therefore, his average was around 4.8. Spin is a key to shooting in basketball. You see, when the ball is in mid-air, it is spinning clockwise. And when the ball hits the backboard, it spins off of it into the hoop. When Victor dribbles the ball and it is in his hand, it is at its highest point in potential energy. But when he pushes it back down, it grows in kinetic energy and loses its potential energy.
How much longer?
Leaving out the fact that you're bad at basketball and you shoot like Victor, most shots are affected by gravity. When you shoot the ball, gravity is pushing down on it at 9.8 meters per second, causing it to go in the curved motion shown by the line.
There's the sugar!
Newton's first law states that an object in motion will stay in motion until a force acts upon it, or an object at rest will stay at rest until a force pushes it. Let's see Newton's first law in real-life basketball. Luke is the force that is pushing the ball over to Victor, and Victor is the force that is stopping it, showing Newton's first law. Newton's second law states that the more force acted on an object, the greater the acceleration. Let's see this in real life. When Victor uses less force to get the ball to Luke, it takes longer. But when he uses more force, it looks more like a dodgeball game than a regular pass. Newton's third law states that for every action there is an opposite and equal reaction. Here's a demonstration. Setting a pick on a defender is a good example of Newton's third law. See, I, who is the defender, am the reaction, and him, who is the one getting picked, is the reaction. And it doesn't fall too good. Work. Work is using force to either push or pull something. So, basically, you're doing work. Shooting is a good example of work in basketball. Watch as I push the ball using force into the basket. I'm doing work. Friction. Friction is the force that is acting against 2 things that are rubbing up against each other. Friction is in every single sport, whether it be hockey, which has little friction, or basketball, which has a lot. Running is a simple example of friction in basketball. As I run, my feet and the ground are coming in contact with each other, which with friction, I can run faster. If there were no friction, I'd be sliding all over the place.
I'm not in this class, but this is basketball. And that's physics.